Hey, Math 7, Unit 7, Lesson 12, Volume of Right Prisms. So it says, first of all, we're going to be talking about volumes today. So we're going to have three prisms here today, which says prisms of the same volume. It says A, B, and C represent bases of three prisms. So this is the bottom part of it, okay? If each prism has the same height, which one will have the greatest volume and which will have the least volume? So first of all, let's remember that volume is found when we take the base of an object and we multiply it by whatever the height might be. So this base currently for A has a base of 3. This is a base of 4. And this one here is a base of 1, 2, 3, 4, 5, 6 times 2 of 12. So if they have the same height, let's pretend that it had a height of 1, okay, for A, B, and C. We would do, the A would be 3 times 1 for a volume of 3, B would be 4 times 1 for a volume of 4, and C would be 12 times 1 for a volume of 12. So the greatest volume would be, in our case here, C, and the least volume would be A, right? Just based upon that, if they had the same exact height. Now, the second question here asks us then, if each prism had the same volume, which one will have the tallest height and which will have the shortest height? So we're talking about volume here. So let's pick a volume here that would make the most sense. We have a 3, a 4, and a 12, okay? Let's go ahead now, because I know that I like the numbers that I see there with a 3, 4, and 12. Let's set our volume equal to 12. And the reason for that is because we know that 12 is a factor for all these ones here, right? 3 times 4, 4 times 3, and 12 times 1. So if I set the volume for 12, how could I get there? So again, taking your base, A, B, and C, for each one, our base here was 3, 4, and 12, and we're talking about what height would I have to have in our H category right here, right, in order to have a volume of 12. Now we could have set this at anything else. We could have said this is 24. We could make some other multiple of 3, a common multiple between 3, 4, and 12. That could have worked just fine. 36 would work, that'd be fine. But let's do 12 for now because it's just easier to deal with. So 3 times what height would get you to 12? In that case there we'd have a height of 4. 4, if that 4 is your base, times a height of 3 would also get you to 12. And if your base is 12 and you had a height of 1, you would get to 12 as well. So in this case here, your tallest is going to be A. That's going to be your tallest one because that's a height of 4. And now your shortest is going to be C. So we actually changed the order from the time of 4, right? Because we had a set volume. And so because it has set volume, we're going to need more of shape A, more stacked up to get to a total of 12. And then we would if we had C. We only need them stacked up one time. That's all you have to have in order to get there, because volume is the base times the height. Let's take a look at a sample here, or something that was on the computer. And maybe your teacher got this out on the computer today and showed you. Maybe you did it yourself. So let's take a look here. It says your teacher's giving you a piece of paper with a shape on it and some snap cubes. Okay, so you probably got a shape that looks something like this, with some snap cubes, some little Unifix cubes, little squares that you play with, right? That have maybe some dots or some things that help hook them up. So now what you wanted to do with that thing is take the shape you were given and then put the squares in those spaces there. You could have done this as well with the online applet, okay? And in doing that, I've already put a few in here already, and you can see I've dragged the squares into that shape as well already. I've already gone over here and put in 1, 2, 3, 4, 5, 6. And to do this, all you have to do is just take one and drag it and drop it in those spaces like so. Oops, that one went too far. Sorry. Sometimes you go a little too far. I'm on my phone here. I use my iPad today, but I'm in the hotel in Seattle still, and I don't have that with me. So we can fill that in like so, and by doing that, what we notice is, come on, we can see that by filling in all those spaces, so to speak. Oops. Alright, here we are. We can just keep dropping those in there. Oh, too far. Oops, my mistake. Can't see what I'm doing sometimes. Around my finger. And fill it in, and one more, fill it in there. Oops, where did you go? Come on. Oops, I want to get rid of that one. If I do undo, I'm afraid I'm going to undo them all. Don't want to do that. Okay, we'll ignore that one, okay? There we go. Alright, so ignore my extra one there, alright? Sorry about that, I can't get rid of it. So what we see here is that I have 1, 2, 3, and 1, 2, 3, 4, 5, 6 in a little grid right there. So 6 by 3, and here I have a 3 by 3 grid right there. So this becomes a 3 by 3, right? 1, 2, 3, 1, 2, 3. So I have a total of 9 in that section. And here I have 3 with an additional 6. 1, 2, 3, 4, 5. Oh, well, 1, 2, 3, 4, 5, 6. And so what's in here is a 3 by 6, which means I have 18 there. So for this base altogether, the area of that base is 9 plus 18, which means I have an area of about 27 is the area of that shape on your grid thing, if you did that right. So use a snap cubes to build a shape from the paper, which we did that there. Add another layer of cubes on top of the shape you built and describe this three-dimensional object. So the idea being, if I go back here, I'm not sure if I can do this or not, but if I take this, can I stack it? I don't think I can stack it on top. No, I can't really do that there. It's not going to work. So it doesn't work. I don't think I can do that. I could rotate it. Oh boy. Well, that's interesting, isn't it? So I can rotate a little bit. I can get rid of some stuff, move that around. Anyways, so you can rotate it there. It's still rotating. You should stop rotating. Stop. There you go. All right. So the idea being that if I take my initial shape, which I had, okay, and then I add up a layer, additional layer here to make it a layer taller, now I have something that's going to be not just 27 by 1 high, but I'm going to add another layer, so it's by 2. So what I have is I have this L shape, a prism, in an L shape, and it's going to be 2 units high because I added another layer of cubes on top of the one I already built, right? So that volume then for part 3 says, well, if I take the base and I multiply it by the height, because my initial base was 27, and I now have it up to 2 units, I'm going to multiply 27 by 2 to find out my volume of that shape, which in this case would be 54 units cubed. Okay? Now right now your object has a height of 2. What would the volume be if it had a height of 5? Again, we'll take our base, 27, and we'll multiply it by our height. That's all we're going to do again and again. You just keep your original base and we multiply it by a new height. And so 27 times 5 is 135. Alright, what if it had a height of 8.5? Same idea. I have my original base of 27, that's the area of the base, times my height, 8.5. And when I multiply 27 times 8.5, I end up with 229.5, like so. Okay? So kind of cool, and you can do it just with the visuals or do it with your cubes to prove that to be the case, all right? So if you had a bunch of cubes, it's easy to do the first layer, but you would need 54 cubes to do the second layer, and you need a lot of cubes to do number 4A and 4B, okay? All right, let's take a look then at the third activity. Third activity says, can you find the volume? We're going to give you some three-dimensional figures here, and I'm going to show you those by using the applet again, showing you what's on my phone. And so for each figure, determine whether the shape is a prism. And then for each prism, only the prisms, we're going to find the area of the base and find the height and then calculate the volume. Alright, so that's the idea. So I'm going to scroll down here and see if I can get the applet to work for our shapes. And so here we go. So our first shape we can see is right here, and we have choice A. We have this little cube here. And it tells me on this cube that, first of all, I can tell that it is a prism because I have a base with a continuous height. So I'm going to say yes to there. Now the area of this base, sometimes when I tap these I get little funky things here. It doesn't quite work the way I like it to be. I have 25, 25, if I touch the bottom down there, 25. So I have a base that looks like to be about 25. I look at the top. Yep, the top is there. Yeah, so that's gonna be fine. So I can say my base of this one here is 25 centimeters squared. Now in terms of the height, what I can do for the height, the way you figure this out, and it's a little sensitive sometimes, if I tap on the centimeter thing there, I can then touch one of these little lines. One of them, come on, any one of them. Whoops, perimeter is 20, don't want that. Let's go undo that. Undo, undo, okay. So let's tap on this one right there. Edge 3, no, not quite what I was looking for there. Let's clear that out. There's a 5, that's what I'm looking for. I can't zoom in here, sorry about that. So I have an edge of a 5, edge of a 5. So that's what I'm looking for here. The height right here is going to be a height of 5. I know the area of the base is 25, which makes my height here, in this case here, it does fine tell me it's 5. So to find the volume, it's 25 times 5, in this case here 5 centimeters, so the first power. So the volume is going to be 125, and it's centimeters cubed. Again, it's cubed because I have a squared and a first, and I add those exponents up. 2 plus 1 makes 3. All right, let's look at figure number letter B. Okay, so here's what B looks like. So B is like this. Okay, and so there's a B. Is it a prism, first of all? Well, does it have a base that then just is multiplied by a height going straight up? Sure it does. It's this pentagon shape, and it's going to be going up that high. So we have a base. We're going to say yes, it's a prism. And in terms of what does it look like, or the area of the base, it says the area of the base is 15 centimeters squared. That's what we can see right there. So we have 15 centimeters squared is the area of that base. Now, the area of this rectangle, it's telling me, is 45 centimeters squared. So that's a little different because I want to find the height. So to figure out how what that's going to be, let's draw a quick little sketch here of the base. The base is a pentagon, right? So we have a pentagon shape like so, and we know that it is 15 centimeters squared, or squared is the area there. But I have 5 different sides there. So let's take our 15 and let's divide that by 5, and when we do that, we have 3. So what this indicates to me is that the length of one of these sides is going to be a 3. And now if I don't have a choice here, I don't have a way to measure that, so that's going to be a 3. So on that vertical guy there, if I know it's a 3 up here, 3 on that length, right, and I have a total of, for the rectangles here, I have a 3 times something I don't know, but it's going to give me a total of 45. I can set this equal to this. I can make 3 times x equal to 45. And if I divide both sides by 3, x equals 15. So that tells me the height of this prism right here is going to be 15. So that's my height. So the area of the base was 15, and the area of the length of the height there is 15 centimeters as well. 15 times 15 is 225 centimeters cubed. It's a little bit tricky to get that figured out there, but it does work out the right way. Again, so that's how we did that there. Let's look at C. So C, we have this shape here, and with this shape, we're going to say, well, I have a hexagon on the bottom with all these things coming up to the top like so. It is a pyramid. Yes, it's a pyramid, but is it a prism? We would say no, it's not a prism. And that's because this shape is changing as it moves all the way up there. We don't have kind of a nice little like rectangle that goes around it there, which we'll talk about another time, but we would say no, it's not a prism in the traditional sense there. All right, let's go to D. For D, here we can see that we have a couple things going on. I have a triangle here, a triangle on the back side, and then you can see you have a square, and a square, or a rectangle shape there. That indicates to me that yes, this is the prism. We have a base. Our base just happens to be a triangle. Okay. Now, for this triangle, it's hard to say exactly which one we're looking at there, but it looks like that our triangle has, in our case here, if I highlight that, our triangle has an area of 24 centimeters squared. When I tap that space right there, 24 centimeters squared. Now I need to find the height. The height is going to be this distance right there. Again, I could rotate this. Oh boy, wish me luck. So if I rotate this to go like that, sure, let's do that. Well, let's keep our triangle. That's our triangle, right, with our base. So if I want to find the height, I'm talking about then the length right here. Oh boy. I don't know what that badge business is all about, but let's get rid of that. Okay, so can I move this? Maybe. Okay, so I'm going to get my measurement tool here, and let's get a length. So it says that my height right here is going to be 6. All right, so from here to here is 6. I can also drop it right there if you wanted to see it's a 6. So 24 times 6 centimeters is my height, and 24 times 6 is 144 centimeters cubed. Okay, cool. Let's try E. And we go to E. Now E, this is just crazy talk right there. Oh, and it disappeared. Well, and there it goes. Where did it go? I don't have any idea. Can I get it back? Nope. Come back to E. There it is. All right, so this one here, very strange looking indeed, and so I can't say a lot of great things about it. What we can say is that it looks funny. It is not a prism. It has some shapes. There's a square there, but then it becomes this triangle thing over there and something different over there. So it's definitely not a prism. It just looks weird. We're going to go with no. Not a prism. Don't need to solve it. Let's take a look at F. On F, we have this parallelogram shape here that extends all the way across. So maybe we can call it a square. Depends on what you want to look, how you want to call it, what you want to call it. So I can't really move it too much there. Oh boy, man, that just keeps sliding around. So we won't do that anymore. So we have a face, and our area of our face here, we could do the top or the bottom. We're going to go with the, oh man, come back. Not being very nice on my phone, that's for sure. Okay, so let's go here. There we go. I like that a little better. Alright, so back to my arrow. So when I touch this guy right there, what I can find is that the area of this face, it's hard to see with my phone, I'm sorry, is 35 centimeters squared. So yes, it's the prism. There's 35 centimeters squared for the area of that face. I want to find out the height there of that length, and the height in this case happens to be, oh goodness, come on, be nice. Oh, be nice. Give me one. Oh no. Oh goodness. I'm not doing very well on my phone. Let's see if I can spin this a little bit. I don't want the perimeter of the face. I can't make those go away. I just want to see how long this is. Oh, there's a number. The number says, there it is, 3. I got it to show, yay. Okay, so the height here is 3. So 35 times 3 is going to be 105 centimeters cubed. And that is the idea right there. Boy, that was super exciting. Alrighty. So, and that is it for that one on that side. Okay. So, you get the idea. Imagine, ready for more. Imagine a large solid cube and a 64 white snack cubes. Someone spray painted all 6 faces of a large cube. After the paint dries, they disassemble a large cube into a pile of 64 snap cubes. How many of those 64 snap cubes have exactly 2 faces that are blue? So think of it like this. If you ever played with maybe a Rubik's Cube before, right? Rubik's Cube has 3 sides like that. That's what Rubik's Cube has. But this has 4. And you can buy a Rubik's Cube of 4 actually if you wanted to. A 4x4. I do have one of those actually. And so it will look something like this. Right? So that's what it looks like. Okay. And a little 4x4. So when you spray this thing, you're going to spray the whole thing with 64 cubes. And the reason we say 64 is you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And 16 times 4 is 64. So when you spray the whole thing, how many have two faces? Well, the corner pieces have 3 faces, okay? The ones in the center, and there's 4 each of them, have 1 face, okay? These edges right here have 2 faces, and of course there's something in the middle that you can't even see in there, and they have 0. So, how many have 2 faces? Well, you're going to have 1 and 2, 3 and 4, 5 and 6 right there. Then you'll have a 7, 8, 9, 10, 11, 12, and the back side 13, 14. And on the back side over here, you'll have 15, 16, 17, 18, 19, 20, 21, and 22. And I think I missed 2 more somewhere. You should have a total of 24 faces altogether. So you have 1, 2, 3, 4, 5, 6, 7, 8. Sorry. So you have 8 on this face. You have 8 on the back face. And then around the middle, we have the 1, 2, 3, 4, 5, 6, 7, 8. You have 8 there in the middle. So 8 plus 8 plus 8 is, oops, 24. What other possible numbers of faces can the cube have? It can have 3, right? And those go with the corners. And the ones that are 3 are going to be 1, 2, 3, 4, 5, 6, 7 in the back corner. You'll have 8 of those. You can have ones with 1, which are going to be 4 for each face. And there are 6 faces. So 1, 2, 3, 4, 5, 6. So 6 times 4 is 24 of those. And then you can have some that have 0. That's going to be the ones you can't see. That's going to be the little block inside of it. So inside of here are going to be some spaces. Okay, they're actually going to be 4 inside that you can't see. Oops, more than 4. Because you have, well, 1, 2, well, yeah, you have 8 actually. You have 8 inside that you can't see. But that's it. I'm going to skip number part 3 for now because it's just more and we're okay. All right, let's move on. Let's go to our summary for today. Actually, we can do a little bit of this one real quick. I'm going to do a little bit of the optional one. And this one is one you might have done in class, maybe not. So you have 4 prisms have the same volume. Here's what the base looks like. Order the prisms from shortest to tallest and explain your reasoning. Alright, when I did this first one here, going from shortest to tallest, I look at the base. This has the base of 6, 7, 8 right here for A. Okay, what's there? This base has 1, 2, 3, and then maybe I have, I got this one. It's kind of like a 4-ish, right? Not quite. So 1, 2, 3, 4, but it needs a little bit more, so maybe I steal that piece there to make 4. I got this one, which can go with there to make 5, grouping those together, and that together might make 6. Maybe I'm about 6 there. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I can group that to make 13, and group that to make 14. And over here I'm 1, 2, 3, 4, 5. Okay, so they all have the same volume, right? Same volume. They look different, but same volume. That means their heights are going to change there. So the shortest one is going to be one with the largest base. That'll be the shortest one. So that's going to be C. Now the one with the tallest one is going to be the one with the smallest base, and that right here is going to be D. Right? So we have 14 and we have 5, and then going in order we have 8 and 6. We have C, A. Oops, sorry, shortest. Shortest. Shortest to tallest. Yeah, C, A, B, D. Order the prisms from shortest to tallest. I think we're okay. So shortest one's going to be C. Yeah, same volume. Yeah, 14 times 1. So you'd be okay there. Yeah. That's what we got there. Sorry, my notes have it the other way. and then I crossed them off and switched them. Not sure why, but that makes the most sense because the largest base is going to be the shortest one. Okay, if the volume of each prism is 6 units, what would the height of each prism be? Okay, so for A, if it's going to be 60 units tall, then we're going to take our area, the base, 8 times the height, and we're going to make it equal to 60 to find out what the height's going to be. We'll divide both sides by 8, and h is going to be equal to 7.5. For B, we're going to say that our base is 6 times the height gets me to 60. Divide both sides by 6, and our height is going to be equal to 10. For C, we have about 14, so 14 times h is going to be equal to about 60. So I'll divide both sides by 14, and when I do that, I end up with, that reduces to 30 over 7, which then becomes something like 4 2/7. Alright, something like that. My answer key says something different, not sure why, but that's what I got there. And this one here, we do 5 times h equals 60. We divide by 5, and so h equals 12. Okay. For a volume other than 6 units, what could be the height of each prism? Well, that's up to you. You can pick another number you want to do there, and then you can figure out a new height there. I'm going to skip that part for now, and so that's something you might have done in class, or maybe not quite sure. Alright, so in summary, a cross-section of a prism that is parallel to the base will be identical to the base, right? They're going to be identical things, it's just more of the same going up there. So we can slice a prism up to find the volume just like that there. It also works with any prism, so as long as we take the base, we can multiply by the height to find the volume for any prism. So once we know what that base area is going to be, we just multiply that by the height and we're set to go. Even with funny shapes like that, if we know what that area is, we just have to multiply it by the height in order to find out what our new volume is going to be. Alright, so take a moment now to do your homework, and then we'll come back and check it together. Alright, homework time. Select all the prisms, and then for each prism shade one of the bases. Okay, so here we go. First of all, in this case here, I have a prism, and the reason I know it's a prism is because I have a prism with a base that's actually a triangle right there. And that triangle then is extended all the way across that way to this other triangle over there, right? That's the idea. So that's how that works. So I have a prism. Awesome. B is also a prism. How do I know? I have this shape right here, this pentagon. I'll draw the top one even though it's not the bottom. It's okay. And that shape there gets extended all the way down to here, up or down there. And I have a height right there to get down to the bottom one. In choice C, it's another prism. How do I know? I have a triangle down here, and that triangle is going to be going up that height right there, no problem. In choice D, again I have another prism. Well, how do I know that? I have a triangle here, that becomes a base, and it extends all the way that way until it gets to this triangle over there. E, however, is not a prism, right? It's a pyramid. And so what happens as this goes along is I do get the same shape, but it's a different size shape as I move up until I get to pretty much nothing at the top. So that one is not a prism. Okay, can I shade a base? Sure, I can shade a base. The base looks like that. It's just going to be different as it moves all the way up. Alright, number 2. The volume of both these trapezoidal prisms is 24 cubic units. Their heights are 6 and 8 units. As labeled. So here's a 6 and an 8. What is the area of the trapezoidal base of each prism? Okay, so knowing that it has a height of 64, remember our base times our height equals our volume, right? So we know in this case here, I have a height of 6, I have a volume of 24, and I don't know the base. If I divide both sides by 6, I find that the base is equal to 24 divided by 6 is going to be 4. So that's the base area of that base right there. In this case over here, again, base times the height equals the volume. I don't know the base, but I know the height is 8, and I know the volume is still 24. So when I divide both sides by 8, the base of this one is equal to 3. So the base of that is 3, and the base of that is 4. That's all we need to know. Number 3, two angles are complementary. Complementary means they add up to be 90 degrees. One has a measurement of 19. What is the measurement of the other? Okay, we'll do 90, and we'll take away what we know, 19. And we have 10 minus 9 is 1, 8 minus 1 is 7, so you have 71 degrees. Next one, two angles are supplementary, 180. One has a measure that's twice as large as the other. Twice as large as the other. So what does that tell me? Okay, so I have one measurement is A, plus one that is twice as large as that one, combined to be 180 degrees. So the measurement of 1 plus one that is twice as much as the first one equals 180. These are like terms. I can combine them to make it 3a, which equals 180. Why? That's like 1a plus 2a is 3a. Divide both sides by 3 to get the a by itself, and a is going to be equal to 60. So one angle is going to be 60. That's that one right there. The other one is 2 times 60. So 2 times 60, which is 120. So that's my other angle, which is that one right there. So I have two angle measurements, one's 60 and one is 120. All right, let's look at number 5. All right, number 5. Match each expression in the first list with an equivalent expression from the second list. All right. So here we have 7 times the sum of x plus 2 minus x plus 3. Looking over here, I don't see anything distributed or whatever, so I'm not quite sure exactly what they want, but let's go ahead and let's distribute this and distribute. So I end up with a 7x plus 14 minus x plus 3. I don't see that there quite yet. So let's put some things together. 7x and a minus x is going to be a 6x. And a 14 and a 3 is going to be a 17. Do I see that anywhere? Sure, here it is. Got it there. Okay. B, I have a 6x and a 4x. That's going to be a combined 10x. And a 3 and a 5 is going to be combined to be 8. I don't see that anywhere, do you? Nope. But what I do know is that they both have a 2 in common. And so I could factor a 2 out of this one. 10 divided by 2 is 5. Keep the x. 8 divided by 2 is 4. Now, do we have anything that looks familiar? Sure we do, right there at number 3. All right, this next one, I have negative 2/5 x, positive 3/5 x. So 3 minus 2 is 1, so I'm left with a 1/5 x. I have a minus 3 and a minus 4, come together to make a minus 10, and that matches right up here at number 1. All right. This one I have an 8x, okay, and my choices are these guys here. This is going to be 24x. This one has an 8x, so I know I'm in good business right there. What are they doing? They're turning all these into add a negative, keep an addition, add a negative, so D is going to go there. And here what's happening with 24, 36 is they're factoring a 12 out of both of those. 24 divided by 12 is 2, and then 36 divided by 12 is 3, so it becomes choice E. All right, number 6. Claire paid 50% more for her notebook than Priya paid for hers. Priya paid X for her notebook, and Claire paid Y for hers. Write an equation that represents the relationship between X, Y, and X. Okay, so what did Claire pay? Claire paid Y, which was how much? It's whatever Priya paid, but 50% more. So, what's 50%? 50% is 100% plus the 50%, right? That's how much she's going to pay. Well, 100% can be written as 1.0. 50% is 0.50. So, as an equation, we'd add that up to be 1.5, and usually flip the order around. So do 1.5x, and that is what we have. All right, that's it for today, and we will see you next time.